Back to another video dedicated to polynomials. That video is relevant to alevel math students as well as for GCC and IGCC students because that's basically the key concept how to work with polynomials. And today I'll show you how to add and how to subtract polynomials if polynomials is the function of one variable. So make sure you remember that polynomial is the function of one variable and it can be written in this standard form. And also in a case if the polynomial is the function of several variables like x, y, z and so on, okay? So we will also perform those operations. So that's why it's key skills in how to work with polynomials questions. All right, so that's also crucial because you need to understand the degree of polynomial or order of polynomials. If this is definitely new for you, so just skip this video and just go back to the very first video dedicated to key concepts of what polynomials are so that you understand. Also, you need to operate those terms like monomial, trinomial, binomial, and so on, okay? That I also explained in the previous video. So today we will start from polynomials of as the function of one variables, and I'll show you how to add efficiently so that you don't waste lots of time. Okay, how to add those two polynomials. So that's why we'll start from addition. And right now we're wondering what's the result of the sum qx and p from x. So q from x indicates the polynomial has the order of 3 because the maximum power of their term with minus x cubed is 3. So this is also polynomial of power 3 because you can see the maximum power of the leading term is cubed. So that's why they're both of the same order or the same degree. If you add or subtract polynomials, no matter which sign you use, so addition or subtraction, so you will always get the polynomial, resulting polynomial will get the same, the maximum power of those two because they're all equivalent to each other. So the resultant polynomial will be as of the power of 3, except for one case when the some terms might be cancelled during addition. I'll show you when, okay? In this case, polynomial might have different power. But the maximum power, anyway, the resultant polynomial will get the maximum power out of 2. If it were, for example, 3 and another polynomial was the power of 2, so the resultant polynomial should have the maximum power of 3 because this is the maximum possible. So this is the maximum possible power out of 2. Okay, hope you get it. So now we're going to add them, and that means we will consider addition. How to add them efficiently? So it's better to arrange in decreasing order. So write each polynomial in standard form. So q from x is simply minus x cubed. That the next term goes with the power of 2, 3x squared. Next goes 8x and plus 5. What I did, I just arranged in decreasing order. So all the following terms will have the power less than the previous term by 1. Okay. P from x, I'll do the same. So I will arrange in the same decreasing order of powers. The problem is with the quadratic term, so it doesn't have quadratic term, but as you remember from previous video, we can use 0 coefficient before x squared term, so that's why we align a term under the term. As you can see, it was cubic one, so that's gonna be the same cubic term. On the quadratic term, it should be quadratic term, but in case of p from x, this term is skipped. But you can just still use this term with 0 coefficient. Next term goes plus 4x. And finally we'll get plus 1, the free coefficient. Now we have the structure term by term, and so on. So we align all the terms for both polynomials. Why? Because that's simply what you already had during addition of numbers, so you can use the column methods here. Okay, so we just put the line on the score, and what we're gonna do right now, we need to add them. So we're just adding those two polynomials. So how to do that? No matter where you start, but I would recommend to start from the leading coefficients, from leading terms, and that's why you need to add minus x cubed and minus 2x cubed. In total, you'll get minus 3x cubed. So here, because that's 0 term, this term simply skipped, so the result is simply 3x squared. So you don't care about 0 times x squared because the result is 0. Okay. Next, plus 12x, and finally plus 6. As you can see, the maximum power of the resultant polynomial p from x plus q from x is going to be 3, as we described before. So we discussed that the maximum out of 2 powers. Okay. If, for example, let's simulate the case when you had probably, instead of negative x cubed, you'll get positive 2x cubed. In case of addition, you simply get 0 because obviously they will be cancelled. In this case, the resultant polynomial will have only the residual terms starting from quadratic 1. So that's why I was telling you that sometimes that might not be the case, that the resultant polynomial will get the maximum power out of 2. In this case, the cubic terms were cancelled. As you can see, the result becomes just only as quadratic term. That might be the case, and so take into account this. So by answering questions, is it always the case that it gets the maximum power? No. Sometimes you might get another powers due to cancelling of some terms. All right, so I hope it's clear. So that's why I'm correct back. And so right now we need to perform subtraction. So subtraction of polynomials is the same procedure. So you write in aligning terms in decreasing order, for example, for both polynomials, and instead of adding, you subtract. So let's simulate just right here. And so here I put all the terms in decreasing order for each polynomial of powers. So, and instead of addition, now we're going to use subtraction. So I'll put the bold minus sign. Now what do you need to do? You need to column by column subtract from the top term the bottom term. Okay, so minus x cubed and minus 2x cubed is going to be minus x cubed plus 2x cubed, so that will give the result of x cubed just. So that's the same 3x squared, stays unchanged. 8x minus 4x, you'll get 4x, and 5 minus 1, you'll get 4. So technically, what you can do, I'll just show you another maybe method that will also work. If you just stick to just addition, instead of subtracting, what you can do, I just rewrite quick all the terms, plus 5. And instead of putting minus, I can still use addition, except for I will change all the sign for the bottom term, for the bottom polynomials for each term, onto the opposite. So that will simulate subtraction. However, still we gotta use addition. That's interesting moment. Instead of minus 2x cubed, I'll change into x cubed, 2x cubed. Then that doesn't matter, but I can write so that to be consistent, you know. And plus 4x, I'll change onto minus 4x and minus 1. So I swap all the signs onto opposite, but I still use addition. So that's sort of algebraic addition. And now we just need to add them as in the previous case. But in reality, what we're doing, we are subtracting from the top polynomial, the bottom one. Okay, so we add and we'll get x cubed, so plus 3x cubed, 3x squared, and 8x minus 4x will get plus 4x and plus 4. As you can see, we got the same result, but through addition of the terms with opposite signs. So that will how you can subtract in other way. So if you're comfortable with the way 2, just use that. Okay, now, so right now what we're doing, we do an addition and subtraction by columns, okay? But what if you're a more advanced students? How to do that? For example, let's consider addition again. So q from x, you will add with p from x. Okay, so you're writing terms, okay? Maybe you can arrange as you like. So I'll always stick to arranging procedure before. So that's why first I'm arranging in decreasing order, for example, and I add. So here I'll add the whole expression minus 2x cubed plus 4x and plus 1. So why I put the brackets? So that you can see the whole expression, because if you subtract, you do the same and you put a minus before the whole expression of what is represented by p from x, okay? So you put a minus before, so don't forget that you subtract the whole expression. You subtract minus px, so that's why you put a minus before the whole expression, okay? So right now, the idea of this method is in defining like terms. What does mean like terms? So the key word is like terms. Sometimes they're called similar terms because they should have identical letter part up to exponent, up to the power. So like terms in this case is going to be x cubed and minus 2x cubed if we add in. So 3x squared doesn't have any like terms here. 8x has 8x has 4x, and 5, let's put double underscore line, has 1 as similar term, okay? Why? Because 5 and 1 just numbers, there you can add them. X cubed minus x cubed you can add only with the same identical term that has the same letter part, x to the power 3 up to the power, so they should be identical completely, except for probably coefficients. So coefficients are different, okay? So now, if you want to add, so you consider q from x plus p from x, so you add in those two terms, okay? So that's why just for, so that not be confusing, I put a plus sign, and now I need to work out addition of those like terms. So we start from minus x cubed, we add minus 2x cubed. So actually what we're going to do, we are going to put a minus sign common and do also leave x cubed as, because the letter part is not changing during addition or subtraction, and you add only coefficients. So minus 1 and minus 2 you'll get minus 3 in total. So that's how you can do. If you're not sure why is that, I'll explain. Because minus x cubed and minus 2x cubed has the common factor, which is x cubed. So you can factorize even with the minus sign. So you put minus sign, and what's left from the first one, always 1 is left, not 0, because, and from the second one, plus 2. So you add them up, you'll get 3. With the minus sign, you'll get minus 3x cubed. So this is why it's happening, okay? But you need to remember that during addition or subtraction, you leave in the letter part unchanged. So in this case, x cubed is unchanged, and you work directly with coefficients. So next, 3x squared, but it doesn't have any similar terms, so you leave as it is. Now 8x and 4x together will give you 12x, and 5 and 1 will give you 6. So that's going to be during addition, and as you can see, we've got the same. We've got the same here, identical expression. So there, just, it's sort of, if you use column method, it's sort of a relief for you if you just do the first steps here, you notice in this case. So that's primarily for GCC and IGC students. But if you're on A level, so it's better to work out using these methods by identifying similar terms and do that, okay? So in case of subtraction, we simply put a minus sign before the whole expression. So we put a minus sign, okay? Let's put a minus sign here. So I just want to, sorry. So I just put a minus sign just right before, and now we subtract. So now we use subtraction of polynomials. So what's the result? What's the result if we subtract those polynomials? The idea is pretty straightforward, the same. I may say you're identifying like terms or similar terms, and except for you put a minus sign. So be careful about that. So double minus, if you expand those brackets, you simply can't swap the signs. So it's better to say that finally you'll get 2x cubed, minus goes here and you'll get minus 4x, and minus goes here, you got minus 1. But now what you're doing is just you simply identifying again similar terms and do the same operations that you have. So minus x cubed and 2x cubed is going to be similar terms, and right now q from x minus p from x, the result is positive x cubed, okay? This has coefficient 2 and this minus 1. Then similar term is 8x and minus 4x, but for 3x squared you don't have any similar terms, so 8x and minus 4x you'll get 4x, and 5 minus 1 is just 4, okay? So they're also similar terms. As you understand, the result should be the same as for the column methods, okay? So I hope you got it, how to work with polynomials as the function of one variable, but what to do if there's a function of several variables, okay? You do the same, you try to identify identical terms which has the same letter part. In this case, letter part might be more complicated. It will be consistent of two or more variables. In this case, there are both of two variables, and right now I'll have shortcut. So right now I'll try to identify similar terms just from scratch, and I'll just perform addition. So right now we're thinking about p1 plus p2 and trying to find results. So we work with addition. Okay, where similar terms? Try to pause video, try identify by your own, and let's compare. So similar terms, xy cube, 4xy cube, and minus 6xy cube, right? They're similar. Next one, y squared x for y squared x, I put double underscore, and minus xy squared. Why? Because the order is different. I mean, the first goes x, then goes y squared. However, here, y squared goes first and then x. But you know that during multiplication, you can change the factors, swap them, and the result will be unchanged. So in this case, you still have identical terms. And that's it, because the rest terms, 1, that's free coefficient, doesn't have here in P2, and 10x squared, y squared, you cannot find here. Okay, xy as well, you can find in P1. So right now, the strategy, you just need to put all the terms in systematic way. So I'll start from the very beginning and just goes in this direction. So I'll get, change the color, I'll get 1 minus 5x cubed y squared. They're unique terms for P1. Then I will add 4xy cubed and the same similar term, minus 6xy cubed. So you do the same. Literally, I'll show you quick. So you do the same. You work only with coefficient because letter part, it stays unchanged. So you put this latter part here, and 4 minus 6, you'll get minus 2. So that's why the result is going to be minus 2xy cubed. Okay, so you can cross them out because you perform this operation and you don't need them anymore. So next goes minus xy squared and 4y squared x. So the result is 3x and y squared. Okay, latter part isn't changed. So again, you kill them because you perform operation. And the rest terms that left is this term and this term. So you just write them out. 10x squared y squared and minus xy. So if you're asked on top of that, maybe write the resultant polynomial starting from the maximum power and use variables in alphabetic way. What do you need to do? You just need to rewrite your expression starting from the maximum power. So maximum power, resultant power here, you just pretend that x, y, they're the same, both x's instead of y, you also use x, and the resultant power is going to be, you just adding them, 3 and 2 is going to be 5. So that's definitely the maximum term, the leading term, because it has the maximum power. So you're writing in alphabetic way, you put in those numbers, you put in those letters, x cubed, y squared. So obviously the next power is 4, and this term was the first one. That's going to be the second one, and that's going to be the third one. So it's hard question which term to use, right? This one and this one, because they're sort of the same. That's why it doesn't matter in which order you put them. So you'll put you put plus 10x squared y squared, and then goes term 2xy cubed, okay? They both are the power of 4. Then goes the power of 3, and this term number 4, which is here. So 3xy squared. Then goes power of 2 minus xy term. So it's going to be 5th term. And finally, you stay with 1 as the last coefficient. So again, the question is here. So actually, for me, it doesn't matter. But if you specify that, I don't know, in most questions, you won't have this, uncertainty. But they both of power 4. So that's power of 5. That's power of 3. Then power of 2. Power of 1 is skipped, and just final power 0 because it's 3 coefficients. So that's how you add polynomials of different variables, so of several variables, okay? So here we discuss how to work with polynomials as a function of 2 variables, okay? Identifying similar terms again. So the strategy is pretty the same as here. However, here is more easier to identify. Here you need to pay more attention and have a thorough look, okay? So with the subtraction, you do the same except for putting minus. I'm not going to demonstrate, but you understand that's pretty much the same strategy. Okay, so that was, I think, complete and detailed explanation of how to add and subtract polynomials. Of course, it takes sufficient time in order to be practicing with that, okay? And in the revision section, you will always find that. So hope you like that. Share this video with anyone struggling with this sort of questions. That was Daniel Dallas, and see you in the next episode.